So welcome, everyone. Last talk of the day. I'm sure you're super high energy, so I'll try to keep this brief, to the point, and also I talk really fast, so you're going to have to pay lots of attention. For those who aren't familiar with Pinterest, it's a visual discovery engine. So it's a place you can go when you want to get ideas for decorating your living room, ideas of what to cook tonight, ideas of where to travel. There's Google for when you know that you want to make chicken apricot tagine. There's Pinterest for when you say, hey, it's fall, I want a nice warming dish, and we can inspire you with lots of thoughts. If you're here for a talk on our data infrastructure, this is not that talk. I put a slide up here to represent some of the technologies we use. We use Hive, Kafka, Spark, Cascading, MySQL, HBase Druid, Redshift, Presto, lots and lots of things. Happy to talk about them more. But what this talk is about instead is sort of the journey of data science at Pinterest. What we do is really fundamentally try to understand who our users are, why they're on the service, how often they're coming back, why they're coming back, and understand the patterns in that so that we can grow our business. A lot of people like to talk about turning data into money. While I believe that data is, of course, incredibly valuable, like that's why I do my job, I don't like this analogy for a couple reasons. And the main one is, when you think about turning data into gold, what you're doing is digging something out of the ground and polishing it up and turning it into gold. And that thing you get out of the ground, you have no control over. You just find what you find, and your job is to look everywhere sort of blindly and find a thing. But the key with actually doing data successfully is that the software at your company or the software somewhere in the world is creating the data you're using. And so it's not a raw material that you have no control over. It's actually something where you can have a lot of impact on the data being formed if you fully understand the connection between the software and the data. One of the common misconceptions I see about data science and software engineering at different companies is that the data scientists are these really smart people, sometimes with PhDs, who go and sit in the corner and think really hard and come up with complicated models. And the software engineers are the ones actually implementing things, doing things day to day, et cetera. One of the things I don't like about this is I'm a data scientist. I try to actually be useful and not just go sit in the corner building complicated models. But also, I think that data scientists can do their job much better if they understand the software part. If you understand where the logs you're working with are coming from, if you understand how Pinterest as a service works, you can analyze it much better. Similarly, if you're a software engineer, you have to understand the data that your program is generating in order to help optimize it better. I think many of you just saw Elena's talk on growth. That's exactly how that iteration works. You build something, you look at the data. You build something, you look at the data. I cannot count the number of times people build something, build the data wrong, and have to iterate twice as many times as they would otherwise. So this is sort of a synergy that needs to exist between both. Data as software, software as data, and a better culture to enable both of them. I'm going to tell a bit of a story today about Pinterest's journey. I joined Pinterest in early 2012. At that point, we had no logging at all. We went to having some logging, but no insights. We had some incorrect data due to external issues. We had some incorrect data due to internal issues. Finally, we had mostly correct data, but then we had to figure out, what do we do as it's getting messy? How do we sort out correlation and causation? And how can we use software to solve some of our data problems? So let's dive right into that. Who is coming to Pinterest? Counting is hard. So first, let's talk about why we care about counting. So if you're any sort of service that tries to get more users on it, which is pretty much any service in the world, you want to know how many people you have. This can help you do things like scale your fleet and buy AWS servers, or heaven forbid, buy your own servers and have to deal with them, which we do not have to do. It can also help you get investment, where you say, hey, we are adding 200 million users a day. Probably not true. We are adding 200 users a day. You should invest lots of money in us. Or sell ads to people by saying we have this much traffic, et cetera. But if you think about an early stage startup, what you're doing is you have built the minimum bare bones of what you need to keep the service going. And if you think about Pinterest in 2012, that's exactly what we were. Our architecture looked basically something like this. So we have a varnish layer that caches some stuff and then directs requests down to our ng app and ng API servers. They talk to each other. Of course, we have to have data. Like when somebody signs up for Pinterest, we need to know who they are, so when they come back next week, we can look them up and find their pins and so on. So we have a SQL server, and it looks like this, and we can query some stuff. And so naively, at this stage, you say, OK, I have a service. People are coming. I want to know how many people there are. Well, you can just query that SQL server. And so you hire a data ninja, and she queries that SQL server, and now you have all your answers. But step back a second. Recall, we're an early stage, fast-growing startup. Our SQL servers are already falling down all of the time because we're growing so quickly and we can't really keep up with things, and we're just starting with sharding, and things are a disaster. And so if she starts querying this database, it's going to fall over all of the time. So the first step is to clone that SQL into somewhere persistent, like S3, where you can query it without actually without affecting your production QPS, and find some insights. And so let's say you do that. You take your data ninja, you pointer to the clone of your databases, and you start asking some questions. And this is what we did. And we said, hey, look, that's cool. We're growing pretty fast. That's pretty great. Look how many users we're adding all the time. We're very happy. But our CEO, being a thoughtful person, said, well, why are we growing? Why are we growing so quickly? But the thing is, this is the infrastructure we have. We can tell how many users we have. We just did. And we can tell some things about them. We know their first name. We know their last name. We know their email address. We know their gender. We know their username. We know how often they want us to email them. In practice, we can't even look at most of these things because they're almost all personally identifiable. But also, they're not very useful. What we really want to know is, where did these people come from? Were they referred by ESPN? Were they referred by Martha Stewart? Were they referred by some cooking website? Where did they land when they came to Pinterest? Did they come in through the home page? Did they come in through someone's profile page? Did they land on a pin from SEO on Google? What did they do when they got here? What did they look at? How did they decide to sign up? What did they do after they signed up? These are all the things that will actually help you drive your growth engine, and we had no way to know any of them. So we did what any self-respecting company would do. Oh, sorry, skipped a step. So we had lots of questions. We didn't know any of these things. Were we growing because we were invite-only and therefore more desirable? Were we growing because we were invite-only and therefore we were sort of a big homogeneous set of people who were all kind of similar? Were we spreading virally through a small community? Were we getting lots of traffic from Facebook? And also, back in 2012, Pinterest was in the press literally all the time in the United States. Were we growing just because of all that press coverage that people were coming to check us out and see what was going on? Is it sustainable? Do new users stick around? What are they doing on Pinterest? Are they going to come back? And so we come to this notion of daily active users. And for those not familiar with it, I pasted a Wikipedia entry. But basically, the idea is you want to know who's actually on your service, who's actually using it. I don't care if you signed up 200 million users yesterday if none of them actually come back. Also, some of them are probably fake. And so if you look at our architecture, we have the varnish layer, we have the ng app and ng API, we have the SQL database that has users and pins and boards and following relationships and all the things we actually need to make our service work. And now we're going to add some things that we don't need to make our service work, but that we need to understand how our service is working. And that's basically logging. So we use Kafka, which is just a messaging service, to write down some useful things. In practice, we created 2 logs called the raw request log, which logged all the things from the ng app fleet, and the raw API request log, which logged all the things from the ng API fleet. And it looks something like this. So for each user, here's a timestamp, here's a path, here's the status of that thing, here's the date, et cetera. And for every single request that comes in, we just write it down, write it down, write it down, write it down. And so DAUs we can now define as users with a request. That's great. Now we actually have an idea who's visiting Pinterest. But hold on. If any of you do email tracking at your companies, which I imagine you do, then you know that one thing we do with those emails, and we embed a teeny little pixel, so that whenever anyone opens the email, it sends a request to Pinterest, and we can say, oh, this person opened the email. We don't just want to know that they clicked on the email, because that's sort of 2 stages down the funnel. This way we can do things like subject line optimization, targeting optimization, and so on, by knowing who opened it before they even clicked. But I just said, it's a teeny little pixel that sends a request to Pinterest. That means it shows up in our request log. And so along with all these nice entries of people repinning things and logging in and visiting other users' profiles, there's these requests that look like this tracking GIF. And so what do? We redefine DAUs to be users with certain requests. So it's not all the users who have requests on a given day. It's the users who have requests, except for a couple special cases, maybe. And so that looks like this. Here's a nice SQL query. People have talked today a lot about SQL. Hive looks a lot like SQL. Here's our query that actually populates our DAUs. Well, not anymore, but did back then. Anyone who has a request in compact view, except for this special path. And in practice, except for this other special path, and this other special path, and this other special path, which we'll get to later. And so now we can actually track the number of people visiting Pinterest every day, which is really great. We can see things like, oops, we kind of broke our service twice. Isn't that unfortunate? And we can see things like, oh, we're growing. Isn't that great? But we still have a lot of questions. Who are those users? Is it the same users every day? Are new ones trying us out? Do people come back often? And we can't answer any of those questions with just our DAU count, so we want to create something like weekly active users. Well, that's cool. We can write a query that looks like this. Look at a whole week of the request log and see who showed up. Or maybe look at a whole month of the request log and see who showed up. Or maybe look at a whole year of the request log and see who showed up. This is a terrible, terrible idea. My request log is every single request that came into Pinterest every single day. If I query a year of it, people will be very, very mad at me because I will have cost us a lot of money, and also it will not complete. So rather than doing this, we create some derived tables. So the derived table is very, very simple. In our case, it's unique actions. We partition it by date and also by action type, which means that it's extensible for lots of different things. In our case, we're using action type 0 to represent DAUs, but now this has, I don't know, 9,000 different action types in it for people who viewed their own profile and then repinned, or people who bounced after visiting our analytics page, or people who spent money on Pinterest for the first time, or whatever else. Point is, nice generalizable schema. Run the query once, and it tells you this user was active on this day, which is all you need to know. And then you can use this, the table looks like this, to answer these questions. Only again, not quite, because these again rely on weekly things, but instead of aggregating the raw request log over a week or over a month, we can just look at this nice, tiny, tiny table that's 1 row per user, aggregate over a week, aggregate over a month, have derived tables for XD7 users and XD28 users, and now we can start to answer our questions. And so we look at it. How often are users visiting? Well, that's pretty awesome. Like, the third most frequent thing that people do besides visiting once a week is visit every single day that week. That's pretty cool. Well, what does next week look like? Well, now we have this table. We can just join it on itself. Take a look. So as you might imagine, next week tends to look kind of like this week. The people who showed up every day last week probably show up every day this week. The people who didn't show up as much last week don't show up as much next week. We can break this out and get a few more insights here. Like, it seems like there's some sort of magic tipping point. Like, if you look at people who showed up 2 days last week, they're actually more likely to not show up at all or to show up once than they are to show up 2 days this week. Or if you look at people who showed up 6 days last week, they're more likely to show up every single day this week than they are to show up the same number of days last week as they did this week. Maybe they were just sick one day. And so we start to get these insights about how our users are visiting, how there's these different cohorts of people who maybe are just testing us out, and those are the ones where you have to invest our growth efforts and say, hey, you don't seem like you understand Pinterest. You only came once this week. Let me tell you more about it. Let me show you our value prop, et cetera. Whereas the people who visit 7 days this week, we don't need to worry about them. Maybe we should break them out separately in our metrics. They already understand Pinterest. They're coming back all the time. And we can do the same thing to look at a whole year of data really, really easily with these derived tables. And so if we look, sorry, I jumped over that query quickly, whoopsie daisy. If we look at the people who are there a year ago and how many weeks they visit in the subsequent year, we see that Pinterest is incredibly sticky. So the single most likely thing that people who visited 1 week a year ago will do is visit every single week this year. The next most likely thing they'll do is visit every single week except one, maybe take a week to go off to the Bahamas. The next most frequent, you see, et cetera. So what did Pinterest learn from this? We can actually count our users. That's very exciting because we couldn't before. And people actually told me I was lying when I showed them some of these graphs many years ago. And also we see Pinterest is incredibly sticky because people are really coming back to the service, and we have these different cohorts of users that we have to pay attention to. What did we learn in general? Data as software. Log your requests. Figure out which requests count. Build derived tables, build monthly and weekly aggregates of those tables so that you can start to answer the questions of who the people are, when they're coming back, what their visitation patterns look like. Data as culture. You want to grow visitors and not signups. We talked about sort of acquisition and activation in the last talk. I don't care how many signups you have, they have to revisit. It is much harder to reactivate someone who came to Pinterest and decided it was stupid than to get someone who's never heard of Pinterest to come visit. So you want to balance those things at the right rate. Monitor for anomalies. So now that we actually have a way to track our DAUs, we can see when something is weird and look into it. And similarly, when we know we broke our service for other reasons, because we have other sorts of real-time monitoring, we can actually measure the impact of those incidents. So we can say, Pinterest was down for 2 hours yesterday, which, by the way, it isn't anymore. This was like back in the day, usually at least, and see what the impact of that was on impressions, visitors, et cetera. Who's coming? Counting is hard. How are we doing? Counting becomes useful. So I talked about a couple of reasons why you might want to count users just for counting users' sake. So you can get investors, so you can get advertisers, so you can have a clue about your business, so you can detect anomalies. But in order to drive your business growth, you want to do a little more than that. So there's your anomalies, there's your growth. Let's talk about a real use case. Signups in the fall of 2012. So I joined Pinterest in the spring of 2012, and we spent that entire summer working on two things. The first was opening up our website to people who didn't join with a Facebook or Twitter account. So you could just go to Pinterest.com, enter your email address, click sign up, and you'd be a Pinterest user. Before that, we'd required authentication through those other services. The second was building apps for iOS and Android, which hadn't existed before. We used to be desktop only. We had a little bit of a janky iOS app, but we built a real one. And so we wanted to know, rightly so, what was the effect of those two efforts that we just dedicated our whole company to achieving. And we got a graph like this, because we can count signups now. That's pretty great. And we see signups sort of have this weekly pattern, and then we launch open signup, and they take off. And then we launch the iOS and Android apps, and they take off even more. And we're like, that's awesome. We're doing what we should be. We're growing. This is great. The choices we've made are paying off. Yay. Unfortunately for us, when we watch those metrics a little bit longer, hopefully this shows up. Yes, great. That growth disappeared. And if you're anyone trying to build a growth team or otherwise optimize your metrics, this is a catastrophe. You're like, I thought I built something. I thought it got some people to come. Now they're not coming anymore. What's going on? And so we started to take a little bit of a deeper look. And if you look at the users we were signing up, I don't know how well you can see this, their email addresses were things like Deborah2104@yahoo.com and Dejancy3741 @yahoo.com and Melanie2942 @hotmail.com. And gee, those sound kind of similar to each other. And then @yahoo.com and @yahoo.com and other email addresses that I can't even say, let alone spell. Side note, we talked a little bit about personally identifiable information in the past. We are not systematically looking at everyone's email. We do observe privacy regulations, et cetera. But in the case of detecting spam, it's one of the things that we can use to help identify some of these patterns. So, little side note. Spam, I just said the word. Yes, these people are fake accounts, and they're completely throwing off our understanding of our business metrics. And so we think Pinterest is growing, but we know a bunch of it is this junk. How much is junk? Are we actually growing? What's going on? Help, help, help. For anyone who's worked on spam in the past, you know it's an adversarial problem. And what I mean by that is the spammer is constantly changing. And everything you do, he's fighting against you. You really want to keep your nice, clean, beautiful Pinterest service clean of spam. He really wants to sell fake Louis Vuitton handbags or get traffic to his ad farm or whatever it is. And so he's highly motivated to respond to anything you do. Every time you change a rule, he adjusts his tactics. You build a new rule, he adjusts his tactics to avoid that one. You build a new rule, he avoids his tactics, et cetera. This makes spam hard. Luckily, if you're just spam filtering your metrics, it's not adversarial anymore. And this is a nice little secret for understanding your business without incurring all of the costs of that iterative cycle. So you can say, I don't care what you're doing on Pinterest. You can just keep doing it. I'm ignoring you. I'm just not going to count you in my metrics. And so when we look at things like signups, we can say, this whole chunk of people, we're not counting them. We haven't told them we're not counting them, right? Like they're not seeing our internal dashboards. And so they don't have the incentives to go iterate, become more scary opponents. And so here's some examples of the sorts of spam we can see. We see people who sign up for Pinterest with a nice quotation as their biography. And that's great. In this case, it's, I was born botanical with the soul of an animal. That's nice. Like, these people seem reasonable, except that there's hundreds and hundreds and millions of them. These are people who, their usernames are like nice women's first names, followed by some numbers, followed by some digits. Again, perfectly reasonable. If you go to their accounts, there's nothing weird there. They have nice little hometowns and nice little pictures of themselves, and it all seems cool, except that there's hundreds of millions of them. And then there's, I could keep going about spam forever. I won't, but here's one more example. This is an account from China. They have created a bunch of boards. They have not put pins on any of these boards, but the boards have very long names. If you want to have a metric about things like board creates, this would be impacting your metric quite a bit. What is each of these boards? It's a biography, shall we say, of an available escort in a different Chinese city with her phone number that you may call if you would like to engage her services. This is not something that Pinterest wants to be hosting free websites for. So, all sorts of different kinds of spam, all sorts of things messing up our different metrics. What are we going to do about it? Write some rules. Each of these examples is a simple rule, right? So I can look at DB users, our dump of our database users, and take out people who have the same name as each other, people who have the same description as each other, people who have the same about me as each other. I can look at our pins and take out people who pin the same image over and over, people who pin the same link over and over, people who pin the same domain over and over and nobody ever saves anything from it, people who pin a set of known bad images. I can look at our event logs and say, again, what are the things that I'm seeing that these spammers are doing? Each one is just a simple rule. Duplicate images. People who create boards called I'm the boss. Believe it or not, that one's real. People who delete and create boards over and over and over again. I can look at our sign-up logs and find suspicious IPs and bad user agents and come in pairs and so on. And I'm glossing over this because the details don't really matter. But for each one, you can just write something down, and then your data will be better. And what that looks like is something like this. So this is one of our rules. This is our actual screenshot of our code. And it says, I have a table. It's called I think these people are lame. Actually, it's called possible spammers data. And it has partitions for each of these rules. And we say this is the set of people named which is stupid, right? It's dumb. But there's 10 million of these people. I don't want them messing up my data. Now I've written them down. Now I can leave them out. And we do this for each of the rules, and you can add things. And at this point, I should pause and say this is a data conference. Of course, you could do fancy machine learning on these things. Of course, you could use these things as features. That would probably be better and give you slightly higher precision and accuracy and so on. But also, if you're an early stage startup, like maybe you don't want to bother with those things because the rules actually work pretty well. And if you overfilter by 1 or 2%, again, it's not affecting those people's ability to use Pinterest. It's just helping you get some sanity in your metrics. And so building this simple rules-based system is about 1,000 times easier than at least more inspectable than building the machine learned system and gets you most of the way. So at this point, we take these different rules we've written, we generate this table called possible spammers data, and now we actually know who's a spammer. We build a little workflow that says, OK, here are the 27 rules that created, or 30, or however many there are right now. This is just a screenshot of our open source workflow tool called Pinball, pretty similar to Azkaban or Airflow if you use any of those things. And we can tell when it's done, and we can build dependencies on it, and we can take the outcome of our real-time spam service, which is this adversarial thing that I'm not touching on right now, but I'm happy to talk about more later, and say, OK, these are all the people that we think are spam, either because we actually blocked them in the product, or because we decided to filter them out of our metrics for all these different rule reasons, and these are the people we're not going to count anymore. And then we take those things, and we can actually do spam filtering. And there's an important step here, which is actually doing spam filtering in your table. So we took our XD7 users table that we talked about last time, our weekly users, we took our monthly active users, and we spam filter both of those things. And we spam filter our user states, and we spam filter our unique actions, and we spam filter our app actions. And this is really important. And so I'm going to actually speak more slowly for a moment. I'm a data scientist. Like, I know the subtleties of our data. I can remember, gee, there were 3 million spammers joining Pinterest today in 2012, and I need to remember to join on them. But if you're trying to democratize your data and you have people from all over the company querying it, they are not going to remember those things. They're going to look at that table and do a count star and call that your number. And so it's very important to have opinionated data that builds in the things you are right. Build these tables that are spam adjusted. That's what that _SA means. So the default place for people to look will not mislead them. They could go to that table and get the thing that you think is true, that you think is right, and they can build the correct conclusions off of them. And again, this is just a workflow. So we say, OK, finally, when we've written that spam users table, there's now, I don't know, hundreds, thousands of jobs that depend on it that try to do spam filtering across our whole company. So we have a single view of who's a spammer, and we can inherit from it in all sorts of places to understand how our business is actually doing. And so here was our graph of signups in fall 2012. We can break it out. That line is very light, but we actually can see a growth in real people that is sustained. So it spikes right away. And then we get more users every day by quite a considerable amount than we had before Open Signup and before our apps. And then we see this this spike in spam that actually starts a couple days later and is huge and variable and blah, blah, blah. And we do not want that to count on our metrics. And it goes away, and it comes back, and it goes away, and it comes back. And now we can ignore it and actually understand the growth trajectory of our company and understand that the decisions we made to launch the Pinterest apps and to open up sign up were probably good for our business. I say probably because who knows if that's actually the cause, but we'll get back to that a little bit later. Data as culture. We can measure the effects of our work. Now that we have a reliable DAU count, a reliable XD7 count, we can look at who's coming and how the decisions we make change that over time, at least temporarily. We understand the importance of spam filtering. So because the Pinterest has lived through the pain of this, now everyone at the company, when they see a graph, they say, oh, is that spam filtered or not? Because they know it's crucial. And so building up that sort of cultural knowledge is incredibly important. Data as software. We can aggregate our data in useful ways. We can build workflows. We can do software engineering. We can build opinionated data sets that capture the knowledge we have and able to democratize it across the whole organization. Doing the right thing should be easy. Doing the wrong thing should be hard. Build data sets that make it easy to do the right thing and hard to do the wrong thing. And we can count again. Hooray. Software as data. Let's tell another story. Stories, yes, we talked this morning about why stories are more memorable. So here's a graph of our daily active iPhone users from sort of fall of 2013 till January-ish 2014. On October 18th, 2013, we launched a new version of the app, and we saw a step change in our growth rate. Well, that's pretty cool. Why is that? Well, the PM sent out an email and said, well, we were featured in the App Store. We saw this huge bump in our growth. Like, that is amazing. We should try really hard to get featured in the App Store. But really, like, that's a really big increase. Are we sure? Are we sure it's just because we were featured in the App Store? Like, did anything else happen? Can we figure out if anything else happened? Maybe something happened. And so he sent this email. Have an iOS device, check out featured in the App Store. So I'm going to read this one aloud. We launched version 3.0 of the iOS Pinterest app today, which represents a huge amount of work from the mobile team. An inspired combination of iOS 7 and Pinterest visual language, the interaction model has been carefully designed. Transitions, gestures, and information architecture were painstakingly thought through. The work has paid off, and the app was included in the featured tab of the App Store. This is a big deal and something that doesn't happen all that often. OK, the second paragraph tells me we were featured in the App Store. The first paragraph tells me we changed a whole bunch of stuff, and also we were featured in the App Store. Like, what are the chances that this gain in growth is only due to that second paragraph? Like, maybe something in that first paragraph has something to do with it. I'm skeptical. That's my job. So let's talk about iOS 7. No one here remembers it. It was October 2013, so let's read this Macworld article on what it did. What changed in iOS 7? Oopsie daisy. Back. Not that long ago, iOS apps running in the background were essentially in suspended animation, unable to do anything until they came back into the foreground. With iOS 7, we had the ability to suddenly start doing things in the background, even if the user wasn't using the app. So what did Pinterest do with that ability? We, in the background, when you didn't have the app open, we'd go get your home feed for you, so that when you open it up, it wasn't blank. Like, that's a really great idea. Instead of opening Pinterest and waiting for the spinner to go, especially if you're sitting on the bus on your mobile connection, your home feed is all there ready for you. You can scroll through things. You can discover things. Life is better. Things are good. But how do we fetch that home feed? Well, we make a request for it, of course. And if you remember how we're counting our DAUs, we're looking at all the people with requests. Here's the new request. Uh-oh. Now we're counting people as DAUs who aren't. And so we said, hey, everybody, sorry about that. Like, I know we're excited about this growth, but maybe you can just hold off, because we think that that growth is a little bit inaccurate. Our CEO, being a thoughtful and intelligent person, says, well, OK, but how inaccurate? Like, can I celebrate some sort of jump, or is it all fake? And so the iOS engineer looked at it, and he said, well, what we're doing is fetching the home feed. The only handler we're fetching in the API is v3 feeds home. That's the only one you need to exclude. And so cool. We took that data, we did some analysis, and found that if that was the thing we excluded, that accounted for only a really small fraction of the DAU gain, something like 3%. So we said, OK, this gain seems real. Things look good. But really, like, things changed a lot. And yes, we're fetching the home feed, but like, that's a big jump. And like, only 3% of it, like, that's kind of really, like, it's bugging me. And so a few weeks later, we wrote this email and said, you know, I just can't. I can't stop. I can't stop worrying about it. I need to look into it a little bit more. At this point, aren't we lucky we built that request log? So what we do is we can look at every single request that's coming in. And we can graph those over time to try to see what's happening with our users. And that builds a graph like this, which is intentionally small. The important things to know, there's a big vertical line for when we launched the new app. Every single API request is in here. Everyone is colored red, except if we start to see it a lot of times, then we color it green. And if it's the home handler that the iOS engineer said we should see a lot, it's blue. And so if you look at the right-hand side of this graph, you see all these streaks of blue. Like, indeed, we are calling the v3 feeds home handler in the background all the time. But if you look closely at this graph, you also see some streaks of green on the right-hand side. Look, streaks of blue and green. Here's what the data scientist who built this wrote. You can easily see long smears of blue, which are background hits to mostly v3 home feed. OK, there was a second handler that was like really minor. These we knew about already. But after the 3.0 app is released, you also see long smears of green triangles. And there are no corresponding smears of green circles before October 18th. The circles are the old version of the app, the triangles, the new version of the app. Obviously, not everybody updates exactly the same time. This makes me believe that when in the background, the app can do more than just fetch v3 home feed. This is a really compelling set of data, right? Like, we look at the graph, it's all cool. Now there's some smears of stuff. It's not the smears we were told there should be. There's extra smears. What's going on? And so the iOS engineer looked back at it. And this is like every data scientist's dream, right? Data informing software. We're actually understanding what our software is doing by looking at the data. And he writes this email. He said, oh, after that discussion, I actually confirmed that the iOS application can be launched in the background, even when they're not visibly running. This might account for those green streaks we were seeing. Data as software. We've actually learned something about how our app is working based on the data. And so now we can start to figure out what our actual DAU count is. So we can say, well, if we just exclude v3 home, it's this red line. But if we exclude home and notifications, which is the most conservative one, it's this blue line. But if we exclude all the things that seem kind of green and streaky, it's this green line. And so we can help our company understand what our growth actually looks like. But that's not quite enough. Data as software. We don't want me to be going back and projecting what our potential use is. We can actually tell in the app when it's active or not. And so instead of having a DA request log that's every single request and just its path and its status and the username and the time, we can have this app state. And we can count people who had app state active as DAUs and people who had app state background as not DAUs. And from here, we can actually tell what's going on with our metrics. And when we implement this, we change our query to exclude background requests. Note that we have to include when the app state is null, because some people will still be on old versions of the app that don't have this feature. And now we have a graph of what our actual growth is. And we can see that that increase in growth was not a small effect of this background fetch. It was like 99% that background fetch. I am not going to go build a team of people whose sole job is to feature us in the Apple App Store. Instead, I might build a whole team of people whose job is to count things correctly. In fact, that's what we did. So I think you've seen now a couple of these examples where we have these extra background fetches, they don't count. Or we have these email requests, they don't count. And in practice, there's a new notifications fetch, and it shouldn't count. And so all these things were systematically throwing off our count of our users regularly. And so instead, we built this explicit DAU ping. So the app explicitly says, hey, I'm open. And then we can just use that to count our users. So instead of having these app state is active and not background, and it's not this request, and it's not this other request, and it's not this path, and it's not this handler, and it has to be this, we just say, if you have this event, that's the server calling me and saying I'm active, I'm active. And we have to wait long enough for this to get deployed so that people have adapted the new version of the app. But now we're counting our users this way. There have been no crazy things for years, which is great because we went public, and so we can't lie anymore. And I don't mean lie, I mean be misled by our own data. And so we can count who's actually there. Data as software. We learned a lot about how our app actually behaves. We learned about changes in activity over time. We learned that explicit logging is much, much better than implicit logging, and that when engineers build features and don't understand how the data that's downstream from them will be consumed, it can cause really, really bad side effects. Data as culture. We learned that we need to dig into good news, right? Like, it would be easy to look at that jump and say, like, cool, isn't that great? We have more people now, things are good. We need to be as skeptical of good news as we are of bad news. We need to dig in and make sure that we're telling the truth, because our jobs as data scientists is to be that voice of truth and of data-informed decisions. And if your data is wrong, that will go poorly. And a shared understanding. As I said, when the software engineers don't know what's downstream of their logs, they are not incentivized to do them correctly. If they know what's going to happen when they add a new background fetch, they can say, ooh, maybe I should track that this is a background fetch, et cetera. So building that shared understanding, building that culture of software engineers consuming their own data, data talking to the software engineers to say, hey, this is the effect I'm seeing, is tremendously valuable. How are we doing? Counting is even harder than we thought. Part 3, avoiding data chaos. So I talked a little bit at the start about writing these request logs, and they're super duper valuable. In addition to the 2 use cases we've already talked about, we can do things like say, gee, it sure looks like it's taking a long time to fetch related pins, or users in this particular country it seems to be served really slowly. Can we try to optimize for people on a slow connection, et cetera? But in addition to just logging requests, it can actually be very valuable to log other things. So in addition to logging every request, maybe we want information when people sign up. Maybe we want information when people follow each other. Where were they? What were they doing? Maybe we want information when people create pins. Was it uploaded? Was it from the bookmarklet? Was it from the pin it button, et cetera? Was it from Nux data? Was it from app install? And so in practice, we're creating dozens, if not hundreds, of these different Kafka topics, tracking different useful things about the organization. And so there's all these logs. In addition to all these logs, there's all these derived tables, because people listened to my advice, and they said, OK, I don't just want this raw log. I want to aggregate it in useful ways. And so if you think about a nice, delightful information architecture, it looks something like this. So you have your tables in S3. You derive some things from it. You derive some other things from those things. Everything's nice and simple. But in practice, like, people may not know about all those tables, and they might build their own derived tables that do similar things, and they might build some other tables that do kind of similar things, and then there's other derived tables, and it starts to look like this, and then eventually it looks like this, and eventually it looks like that, and like things are a mess, and nobody knows where anything is anymore. Data chaos, table proliferation. So what can we do here? Again, opinionated data is better than big data. Having a golden source of data where people can say, I know where to get revenue. It's in bi.add daily stats. Don't look anywhere else. I know where to get DAU. It's event type 7137. Don't look anywhere else, is incredibly valuable. That's weird. One of my slides disappeared. Well, here we are. The other half of this is JSON and how you store data. So step back a little bit again. Pinterest in 2012 started logging some stuff. But we're also running around like chickens with our head cut off because our service is falling over all the time. What's the easiest way to log some stuff? Make it JSON. It's just a string. You can stick whatever in it you want. It doesn't have types. You can just stick things in it. It has numbers. It has strings. It has whatever. It has all the stuff you need. And then you can parse it later, and things are good. But if you deprecate something, there's no real way to deprecate it. It just kind of sticks around. If you add some sort of Boolean later, it's null for everything if you're doing lazy updates. But it might be falsy if it's things like private. So we introduce secret boards later. And so a null for private means it's not private, it's public. But we introduced email unsubscribes later. And so a null for email updates means we can email them because they haven't changed their email preferences. And so it just gets really, really messy to think about how to interpret this data. And we can parse it. It's fine. But it's quite slow. And so in practice, we might do it once and then reuse the derived table. But then we're sort of, every time we update the schema, we have to write a new query to build this derived table, and we're losing a lot of the benefits of having that untyped schema to begin with. And so in practice, as our organization became more mature, we moved towards something more like Thrift, where you have an actual schema, look a schema, defining the things you can put in there. And it can be simple, it can be mostly ints, it can be nested versions of other bits of schema, and you can actually look into each thing and understand what's going on. And as you add new fields, you can comment that they're deprecated, they're all optional, so when they are deprecated, nothing has to go away. Like, things are good, things are strongly typed, backward compatible code comments, as opposed to JSON. Untyped, ad hoc updates, undocumented. If you look at this list, it looks a little bit like what you might think of with a software argument of, should we use Python or should we use C? Well, one is strongly typed and one is untyped, and let's all get up in arms about it. Data as software. And I think the solutions to the data table proliferation I talked about are also similar and also rooted in software. So when there's a proliferation of tables, no clear ownership, duplicated work streams, lack of schema, you can fix those things with things like a central data repository and key shared tables and deprecation of tables. And that's analogous to what we do with software. Key central code repository, like everything lives in Git, test for accuracy, deprecate unused code, use shared functions, et cetera. So avoiding data chaos, use well-structured data, have it be well understood. What have we done so far? Cloned our databases, added Kafka logging, built workflows behind derived tables, removed unimportant requests, squashed spammers, understood our app, integrated independent requests, added explicit logging, created data schemas, added tests for data accuracy. And where did that get us? To counting people. Hooray. How do we grow? Counting at internet scale. So remember when we talked about, oopsie daisy, sorry, I forget that's not the back button, how we grew. This looked like a pretty plausible story, likely because we were featured in the App Store. Everything we do as data scientists is trying to find somewhere on the spectrum of certainty between correlation and causation. Unfortunately, most of the time we're somewhere over here. Even more unfortunately, most of the time we think we're somewhere over here. And that leads us to believe things that aren't true. Our goal as data scientists is to move more toward causal inference. Here's a graph of per capita cheese consumption compared with the number of people who died by becoming tangled in their bed sheets. And I can tell a story about this where I ate a bunch of cheese, had bad indigestion, went to bed, swung my arms all around, got tangled in my bed sheets, and died. And it sounds remotely plausible, but so did this story. It's perfectly reasonable. Our job as data scientists is to do things like A/B testing to separate correlation from causation. I'm a little bit short on time, so I'm going to skip through sort of the mechanics of A/B testing and jump to sort of the important things I think here. Making sure your culture of experimentation includes things like understanding statistical significance, understanding novelty effects, understanding user segmentation, understanding that even when you see a difference at the p equals 0.05 level, it could be because that was there before the group began. Doing the right thing should be easy. Doing the wrong thing should be hard. Use your tools to build opinionated data sets. Only show significant differences, et cetera. Counting at internet scale, data as software. Leverage A/B testing. Scale insights with tools. Doing the right thing should be easy. Doing the wrong thing should be hard. Data as software. Data as culture. Leverage A/B testing, actually get people to buy into it and do it. Use shared tools that help incorporate things like significance and novelty effects, that people aren't making the same mistakes over and over again. Evangelize your decision framework. Data as culture. Here's what we talked about: how we got everything wrong, counted people wrong, had spam, background fetches, all the things that messed up our metrics. What did we do with that? We tried to get more data governance, get opinionated data sets, and get people to buy into the culture of A/B testing in order to automate metrics collection and know we are going in the right direction. Culture of experimentation, I have lots of things to say about that, but basically evangelize your product decision framework so that you know you're going to test even when you know you're going to ship things, and you know what the questions you're going to ask will be. That's all I have. Thank you.
Well done. We have 1 minute and 45 seconds. We can answer a couple questions, I think. Are you currently still using a rule-based spam detection method?
Yes, we currently use both machine learning and a rule-based spam detection method. So some of those rules are now features in a machine learned model that's in sort of the real-time spam detection. That's more machine learned. And then for our filtering, we still have a number of these rules in place because they're simple and they work.
Why was Pinterest spammed so much?
Ooh, good question. People want to be able to buy followers, or I should rephrase. People want to be perceived as very famous and popular, and in order to achieve that, they sometimes buy followers. If you want to buy followers, the easiest way to do that is to have a bunch of robots that you can make follow people. Also, Pinterest is one of the top destinations on the internet, and so people have incentive to get traffic from their websites from there, and so they create spammy pins and hope that we'll show them to people so they can sell their fake Louis Vuitton handbags.
Was the login to continue pop-up data-driven?
Oh, I think you're talking about when we changed things so you couldn't see anything anymore unless you logged into Pinterest. Yes, it was data-driven, and it made me very sad, and we've gone through many iterations of it. The thing about having a sign-up wall is it makes a lot more people sign up, especially right away. And this is where sort of understanding your cohorts and your visitation is really important, because right away, you get all the people who've been visiting Pinterest all the time for months, and so they understand it. And so when you look at your things like acquisition and activation metrics, they look good because it's people who have been searching all the time. But over time, the value of that wall decays very quickly, because now you're getting people who are like, I have no idea what Pinterest is, you're making me sign up. Either I'm bouncing, or like I'm signed up and confused and I don't get why I'm here. And so we actually made it really strict, I would say. Like everyone had to sign up. And then we backed off over time as we understood the value of having people at least explore a little bit before they were forced to sign in. And so now we try to strike the right balance of letting you explore a little bit and then saying log in to continue. I apologize that you can't see more. But the way we make money is and the way we personalize is by having you sign in. And so we can show you more relevant content. You can actually save stuff. And also eventually we can sell ads.
All right, and one more question. Engineers tend to be busy building features in startups without capacity to consider downstream data implications. What's the best way to build this culture?
I think the best way to build that I shouldn't say best. The most foolproof way to build that culture is to have a couple terrible things happen, where maybe you don't have the right data and you make the wrong decision, or you thought it was the right decision and it wasn't. And I think I talked through a couple of those in my stories. There are many, many more. But I think when people understood, oh, OK, if we shipped this feature, we would have decreased this key metric of ours by 30%. I'm really glad we measured it and didn't do that. That helps people understand why they want to do A/B tests. When they say, oh, gee, we didn't understand how our business was doing for 3 months because we were counting DAUs wrong, they're much more incentivized to sort of do things correctly. So like, yes, you want to move quickly. Yes, engineers are busy. But I think if they can understand and use the data themselves to be making their decisions, they're much more bought into making it correct.
All right, thank you very much.